Hi, I'm Neil. In this video I'm going to talk to you about 6 steps to becoming a cloud expert. Let's get into it. Right, let's dive straight in. Number 1, master the core concepts. This is quite a big subject, so we're going to go through a couple of core concepts in this. First one being virtualization. This technology has been quite revolutionary for IT. Back in the days with data centers, we had VMware come along, and that enabled us to use the bigger machines but be more cost effective about their workloads and what they're used for. It also enabled developers to develop locally on an environment very similar to what we might call production, with stuff like Oracle VirtualBox and Hyper-V running on the Windows servers and Windows desktops meant we could for the first time nearly have a production environment locally. We had Docker. The main difference between Docker, of course, and virtualization, if you're using VMware or Zen or something like that, you're providing the whole operating system, whereas Docker is sitting on top of that in a application isolation within the operating system. Infrastructure as code. Being able to have code create our environments is extremely useful because we can keep that consistency. In fact, because it's code, we can then test it, so we can be sure that the result that we're getting is what we're hoping for when we write the code. Infrastructure as code allows you to define stuff like network switches, NAT gateways, servers, of course, and a whole environment that you need in the cloud in order to provide your environment for your application. And having it as code enables us to do it again and again. One of my customers was so positive about this experience that on a Friday they'd take a backup and then destroy all of the services and stuff they had running in Amazon. And on a Sunday, early hours of Monday morning, the infrastructure as code would then run, and we knew that we'd get exactly the same environment back as we had on a Friday once we'd restored the data. This is good because it's repeatable. It's also good because it saved the customer money on their AWS bill. Configuration management. So we've got infrastructure as code that's given us a server and it's sitting in a network and it can talk to things. However, it's not particularly usable. Configuration management can help us out with 2 stages. The first stage is to provide what many call a golden image. This is one where it's got the base operating system and the utilities that every server needs, as well as those security patches. We can use configuration management, such as Ansible or Puppet, to create that image using a tool such as Packer. Once we've got that image, we upload that to Amazon. When we create a server, we then tell it which image we want it to use. So we've used configuration management in order to provide us with a golden image. We've got a server running and it's got a base operating system and all those security patches. But now we need to give it a personality. So we can use configuration management once again to provide that personality, like a web server or a database server. And because this is all in code as well, it's repeatable and testable. And automation is also a part of that. We can get the computers to build themselves. Programming languages. Now this isn't really possible without being able to tell the computer what to do. So our infrastructure in code might be in Terraform, which is a language of sorts. Some might argue it's not really a programming language because it doesn't do programming very well. But it has some of the core concepts. It has modules, which you could call a function. It has extensibility, which you could call libraries. And it is a language. I mean, it's written in HTML, which enables you to have a clear idea of what you're building. If we're using Ansible or Puppet, then we've got a language to describe what we want installed on the server and how we want it configured. I'd recommend that you have really good experience of programming language. First one being batch programming. So understanding how bash works and how Linux commands works. is very important to what we do. Python is also a very, very popular language. In fact, Ansible is written in Python. Understanding Python gives you the ability to create web applications, back-end applications. So once you've got Bash and once you've got Python, then it's kind of useful to have maybe a third tool. Golang means you can build a small little tool and not worry about dependencies, which is really useful in our server building world, because how can we tell the server to install dependencies before we've installed the dependencies? So you might need a little utility written in Golang which doesn't worry about those dependencies because it's all in one package. So my recommendations would be learn Python, Bash scripting and Golang. Source control. We need to save the programs somewhere. We need to save the configuration as code somewhere. You don't really want it to be the only person with the code on your machine. The servers can't run it from your machine. You can go in a source control system, the most popular of which being Git, in order to version your code so you can see what changes you've made. You can see who's made the changes as well, which is somewhat useful. When you're looking through code and you don't quite understand it, you can go ask them about it. Storing the source code somewhere externally also means that the servers can download it and run it. Somewhere like GitLab or GitHub enables us to share the code not only with our fellow team members but also the servers so that they can do their automation work. CI/CD, 4 little letters. Continuous integration is where we're running the same code across multiple environments, usually in big pipelines, so that we know that development looks the same as QA, looks the same as staging, looks the same as production. And CD is continuous deployment. This is where we want to have as many small deployments as we can. It's much easier to roll back a small deployment or to patch a small deployment with fixing forward than it is to save them all up into one monolithic deployment event weekend where you're working until 3 in the morning because it's not quite gone right and you have to roll it all back. Continuous deployment is continuously deploying tiny little bits all the time and testing. That way we know what's all up to date. If it's in the source code, it's probably deployed and everyone knows where they stand. And we avoid those big long deployment weekends. And the last bit of the master the core concepts, we want to be lean, we want to be efficient. The benefits of running a lean system is to try and reduce waste. And one of the biggest wastes that I see is handovers between teams. If you can't do something in your team, then you've got to ask somebody else to do it, which means you've got to tell them what you want. They've got to find time to do that and do it, and then come back to you to tell you that they've done it. And all that means that you might be sitting on your hands doing nothing. So that's a waste of time, and if we can reduce those, then that's even better. Scrum is about managing tasks. There's a great book about it called Scrum. I strongly recommend you read it if you've not done so already, and we can see how working together as a team and getting things all done delivers products really quickly. And Kanban is a way of visualizing the tasks that are currently in flight. It quite literally means board. And we can see what's going on and what everyone else is doing, and again it's talking about working together and getting things done. So step 2, get practical experience. Master the tools. The tools I'm talking about, Vagrant allows you to spin up virtual machines either on your local machine, or if you wire it up to AWS it can spin them up in AWS as well. Configuration management, I suppose, is the best use that we've got for it, because you can spin up a machine. Vagrant understands the configuration management tools that are out there, like Puppet, like Ansible. Does it work? Run some tests. If you're getting a bit more advanced, you could run Kitchen or something like that. It comes with the Chef toolset. The beauty of it being infrastructure as code and code in general is you can just rerun it and tweak it, rerun it again. Terraform, very popular for configuration and infrastructure as code, where we're spinning up whole environments, switches, load balancers, servers, that sort of thing. Terraform also comes with lots of providers, so you can get it to talk to AWS or Azure. And Ansible, I mentioned configuration management, can work in conjunction with Vagrant and Terraform and Ansible, all work together friendly and be able to spin up servers, define that personality. So you want a web server today and you want another server next to it, it's a database server, have all that in code in Ansible and practice doing that. And all this is to an end, is to have web applications. Web applications can be written in Python, they can be written in JavaScript if you're doing more front-endy stuff, and maybe PHP, apparently that's still around. But by creating a web application helps you understand your customers, assuming your customers are developers. So to be able to build a platform for them to roll out their own web applications, build your own web application, see how it fits together. And Git, most popular tool for version control and source control. Understand how to create a commit, pull, push, PRs, merge conflicts, all that fun. Because once you're working in a team, then you'll need to understand how to work with shared code. And downloading Git, looking through the examples, really set you on a good footing. And Jenkins, the most popular automation tool out here. Some people call it CI/CD. It allows you to create jobs and pipelines and automate them based on triggers or time schedules. My customer I mentioned earlier, where they destroyed everything on a Friday and started it all up on early Monday, it was Jenkins on a time schedule that enabled them to do that. Step 3. Keep up to date with new tech. IT never stays still, and the DevOps and cloud space is no different. So you can follow blogs such as mine, the AWS blog, where they tell you about new features, new services. There's not a week that goes by where AWS aren't bringing out a new product. DevOps Weekly, link in the description. Gareth Rushmore also releases a weekly blog, email that has a number of stories around the web of what's going on that particular week. And keeping up to date is one of the easiest things you can do to stay on your game. A couple of years ago everyone was talking about Docker, then Kubernetes, and more recently serverless. Gain a qualification. So this is one of those chicken and egg things. So gaining a qualification kind of breaks that cycle. Cloud Academy have a number of courses that will help you gain the knowledge towards qualifications, like an AWS accreditation. Having a look at what they've got there. There are other YouTube videos as well where you can do that, but this end is getting a qualification, so you can put that on your CV and say, look, Mr. Employer, I know what I'm talking about because, in this case, AWS say so. Step 5. Understand cloud platforms. So this is kind of where it's all leading to. What is a cloud platform? It's somewhere where developers can host their applications. Amazon provide the infrastructure, but they don't necessarily provide a platform. I mean, you could say they do. Serverless is where they're coming closer to just providing somewhere where you upload your code and then we'll run it for you. You provide lots of tools so that the developer can get on with what they do. I mentioned the lean thing. It's getting out of the developer's way so they can just develop code and deploy it. Providing those tools for them means that they can go on and they can deliver their best work. But on the platform, we've also got to look after the infrastructure side of things. Scalability being a big one. We want to make sure that we're using cloud resources efficiently, but we've got that balance of cost versus performance. More servers means more cost, but it also means more performance. If we've got lots of customers waiting to do whatever they want to do, or maybe we have to batch it up and they'll have to wait a little bit if it's a cheaper service. In the COVID pandemic, the supermarkets suddenly had a huge demand for online deliveries, and you could go onto their website, and if you were lucky you got a web page. If not, you just got an error message. And it took them a little while to sort this out, because they had to balance the cost and the performance. They could have just scaled up all the servers, but then it would have got a poor experience lower down, because then there'd be no one to deliver the shopping that you've just ordered. So sometimes scaling up the cloud platform is not desirable, because it relies on another system or people in order to deliver service. At the end of it, coming up with another solution is possibly the right thing to do. If you don't have an endless pot of money, then you can't keep increasing servers, because you have to keep that cost reasonable. So part of understanding the cloud platform is how a 3-tier application or cloud-first application looks like. They are usually following the same pattern. There'll be a front end that the customers or the web users see, and that might be written in JavaScript or something like that. Might even be an app on the phone. But it's the front end of the web service that we're hosting on the platform. Behind that, there'll be a second tier of servers, and these servers tend to do the more of the business logic, like sending out emails or processing the orders or talking to the database. You don't usually want the front end talking directly to a database, because that gives a possible way in for hackers to leak the information in that database out through the front end. So the front end talks to the back end then talks to the database. Much more secure model. And it allows you to scale up the front end for lots of customers, so they get a good service, fast reaction times off the web server. And we can scale up the back-end servers when we're doing more intensive back-end stuff, like when we're processing the orders or sending out all of those notifications on email. By building your own application, you can understand what the platform needs to deliver. And I'm sure if you talk to the developers, they'll tell you what they want to deliver. But sometimes it's about asking the right questions. And if we already know what they want and the patterns that they're following, then we can deliver some of that for them. And understanding the cloud platform is easier if we're automatically building the servers. If we've got monitoring as well, it means that when we see a server get busy, we can just automatically build a new server, add that into the fleet, we've got more servers. Especially important when we're monitoring is when that demand's gone away and we can scale back down. After all, we don't want to pay for servers if nobody's using them. But by automatically building servers, we can create them, destroy them at a whim. We can support batch operations, schedule workloads, sending the batch of emails out, or a business intelligence operation where we're creating reports and things. We only want those servers temporarily, spin them up, build them automatically, run the reports, and then we can scale them back down again. So the last one. The last step, attend meetups. There are meetups in your area. Before the pandemic there were loads, then it went online so that we could still get our fix of presentations and learn the new stuff, the latest stuff. And now they're coming back into the real, let's call it, find that next opportunity or to share your knowledge. You might learn new concepts and, worst case, just enjoy the food and beers. So there we have it. A summary of the 6 steps to Cloud Expert. Number 1, master the core concepts. 2, get practical experience. 3, keep up to date with new tech. 4, gain a qualification. 5, understand cloud platform. And 6, attend the meetups. Until next time, have fun.